Hi, today I'm going to do a few queries on add maths, especially the functions chapter, and that too specifically modulus functions, inequalities. Yeah. So now let's get into the first sum of exercise 2F.1 of add maths of Haese. Yeah. Now question number 1 is this, okay, where there is a graph of this modulus. Before I go on to this, one step prior, okay. I'm simply going to draw a graph of y is equal to x plus 3 without the modulus. I repeat, this is with the modulus. I'm going to first draw it without the modulus, which is a simple linear graph. I'm sure you all know that by now. Now, when they ask you to draw to the modulus, what you simply do is, whatever part is below, when there's modulus, obviously the value of y can't be negative, right? So whatever part is below the x-axis, you simply draw a reflection of it on the x-axis, a mirror image kind of a thing. And that portion of the graph goes on the other side of x-axis. So it's basically a mirror image or reflection over the x-axis. Okay. So now your graph will look like something like the red line. Ignore this one. Yeah. So your graph, instead of this is going to be the final line of y is equal to modulus x plus 3. Let's take another graph. Y is equal to 4. Now they will intersect. Correct? It looks something like this. Yeah. So they are going to intersect. Now the first question is 1a, state the intersection points. Obviously, where they intersect, -7, 4 and 1, 4. Correct? Okay till now? Let's move ahead. 1b. Now what is in this? Solve all values of y have to be less than 4. So this is solve for modulus x plus 3, where all values of this have to be less than 4. Okay. Now I'm going to first solve it in algebra form. Okay. In algebra form, you know that if modulus of x plus 3 is less than 4, and if I remove the modulus sign, I have to put a -4 and +4 on either sides. Correct? Now if I subtract 3 from both sides, what do I get? I'm doing, this becomes a -7 and this becomes a 1 when I'm doing -3 on both sides after this step. Correct? So my x value has to be greater than 1 and less than, has to be greater than -7 and less than 1. Correct? Here, x has to be greater than -7 and less than 1. So this is the algebra solution. Okay. Now let's look at a graphical solution. If you didn't have time to do it in an algebra way, correct? Now you have to only do it graphically because they're giving you the graph in the question, correct? So what does it say? It says, find, this is the condition that has to be satisfied. What is the condition? This, that all y values have to be less than 4. Now, where this is the y, correct? Y axis. So all the y values have to be less than this 4. You know, this is y equal to 4. So all my y values have to be less than 4. So they have to be in this bracket. Correct? So what will be my x values which will satisfy this condition? Which condition? To keep the maintain the y values lower than 4. So which are my x values which will satisfy that condition for y? Okay. So here, the x values that satisfy the above condition have to lie between -7 and 1, excluding the -7 and 1. Correct? I cannot write this along with the equal to sign. Less than or equal to, greater than or equal to. I can't. I have to only write without the equal to. Why? Because in the question, are they saying less than or equal to 4? No. Okay. So I only write this. So this is B part 1. Correct? Let's look at B part 2. Now here, modulus is greater than or equal to 4. Okay. So all the y values have to be greater than 4. So it is this part of x-axis and this part of the line basically. So this portion and this portion. Correct? So let's first solve it algebraically and then we'll solve it graphically. Using algebra, here, modulus is greater than or equal to 4. When I remove the modulus, there's a -4 and a +4. I do subtract by 3 on both sides. -7. So x is less than or equal to -7 and x is greater than or equal to 1. Here, in the graph. If we didn't have time to do this, we can also spot it on the graph that wherever x is less than or equal to -7, my y value is greater than or equal to 4. This is what they want, this portion of the graph. And whenever my x is more than or equal to 1, my y value becomes more than or equal to 4. This is 4. I want y values to be higher than this. This is my 4, higher than this. So that's this portion of the graph and this portion of the graph. Cool. Now, x is less, yeah. So this is using the graphs. Now here, because the equal to sign is included in the question, we can also use these signs in the answer. Yeah. So that's it for the first sum. I'll put up the second video, second sum soon.